Hello. A GATE 2022 question from set 2 is solved. The statement of the problem is given here. You can read. The schematic is shown here. The device given in the problem statement is a turbine. Steam enters the turbine and leaves the turbine. Turbine is a work producing device. So this is a work producing device, and also it rejects heat. What are the data given in the problem statement? Mass flow rate. So how much quantity of steam is flowing into the turbine per unit time is given. Mass flow rate, m dot. Specific enthalpy at inlet. So this is the inlet. What is the specific enthalpy? It is given there. Entropy, that is specific entropy at the inlet, is given as 6.5 kilojoules per kilogram Kelvin. Heat loss occurs at a temperature 500 Kelvin. What is the heat loss is not given, but the data given is the temperature at which heat loss occurs. The specific enthalpy at the exit is given. Similarly, specific enthalpy, entropy at the exit is given. And we need to find what is the work output from the turbine, that is W dot in megawatts. What is the solution? Turbine is a steady flow device, and hence we can apply steady flow energy equation. W dot we need to find out. Mass flow rate is given. H2 is given. H1 is given. We can neglect kinetic energy terms and potential energy terms since they are not given. Therefore, if you know what is Q dot, then we can estimate W dot. Q is not given, but the temperature at which it occurs is given. Therefore, we need to make use of change in entropy. We know change in entropy, ds is equal to dq divided by T. From this, we can calculate dq. The equation can be rearranged like this: dq equal to ds multiplied by temperature. Temperature is given, and what is the change in entropy, Ts, when the steam flows across the turbine is given. We can substitute those values, which yields dq is equal to minus 100 kilojoules per kilogram. Steady flow energy equation already we discussed, or we saw in the earlier. Since the kinetic energy, potential energy are not given, those terms can be neglected. Instead of Q dot, 500 multiplied by minus 100 is given. So what is that? Q dot is equal to m dot multiplied by dq. dq is minus 100, and m dot is the data given in the problem. It is 500. So m dot is in kilograms per second, and this is kilojoules per kilogram. When you multiply these two, it will give kilowatts. The quantity we need to calculate is W dot, leave it as such. And on the right hand side of the equation, we have m dot 500, and H2 is given. H1 is also given. Calculating this one yields W is equal to, in megawatts, 450. Thank you.